Hello everyone. We are going to see the image formation by the lenses. In lenses, either we have a convex lens or concave lens. So before we start the how images formed by the lenses, first of all we want to see the rule. What are the rule applicable to draw the ray diagram? In that condition, we are going to make a first rule. The first rule speaks that in case of a convex lens, let two focal points here, any ray parallel to the principal axis always passes through the focus. But the same if in place of convex lens, if there is a concave lens in the practice and parallel ray of light allowed to fall on the concave lens. It has a diverging nature. This nature is called converging lens nature, and it is shows diverging nature. It seems to come diverges scattered in this direction, seems to come from focus. We are knowing focal length of convex lens is positive while of concave lens is negative. So this is the first rule. Number two, the rule number two is this: in case of a convex lens, the rule is that if any ray of light passing through the focal length in convex lens, it becomes parallel to the principal axis. The same rule when we see in case of concave lens. Here, if a ray of light falls on a concave lens, if it's become after refraction parallel to the principal axis, if it happens, then it seems to appear to come here from the focus. See, very important, the second rule. The first rule is this, second rule is this. Now see the third rule. This third rule is what? See, let it may be either concave lens or convex lens. Let this is the optical center. Any ray passing through the optical center, it is undeviated after refraction. No deviation, no bending takes place. No bending takes place in case of either convex lens or concave lens. So keeping this three rule in mind, parallel to the principal axis passes through the focus in convex, seems to come from focus in the concave, passes through the focus, becomes parallel to the principal axis. If it's in case of concave lens, if it is parallel to the principal axis after refraction, seems to meet at focus, and any line passes through the optical center, it's undeviated. Now see the image formation of lens by convex lens. And this image formation by lens, in these lenses first we will take convex lens. So in this convex lens the image is formed under different cases. The first case is taking as a when object is at infinity. In case of this, let us see the diagram. When object is at infinity, a convex lens is here, right? And let an object is at infinity here. Take a ray of light coming from infinity. This is the optical center. According to the rule, it is undeviated. The ray number 1. Ray number 2, if it is passes from the focus, it becomes parallel to the principal axis. The first ray and second ray intersect this point. The image is formed here. The position at where image is formed is called focus. Very small image. Let us see the characteristic. If image is formed on another side, it is called real image. Second, real image is inverted, opposite to the object. Arrow is upward, arrow is downward. So, inverted. Position at F, the third point. And fourth, highly diminished. Highly diminished means very small in size. Very small in size as compared to the size of object. Highly diminished. This is the first case. Now we see the second case when object is in between infinity and 2f. 2f is also called C, center of curvature, in a convex lens. See the diagram for this is convex lens, focus point, two F is called C. Let an object is here. AB. We are taking a first ray parallel to the principal axis according to the rule discussed here, always passes through the focus point F. Another ray, first ray, second ray, passing through the optical center O, undeviated. No bending obtained when it is passes from optical center O. This is the point 2F. The image is here of AB object A dash B dash. So see where image is formed. Here in this case, just like a previous one, the four characteristics are real, inverted, Third, between f and 2f is small in size. So small in size is also called diminished. So these are the four characteristics through which the image is formed here in this case. Object is at 2f. Object is at 2f, see carefully. Take a principal axis line. This is f, 2f. This is f, 2f. Take an object as 2f. Two rays. First ray parallel to the principal axis always passes through the focus. Second ray passes from optical center according to the rule of refraction undeviated. Where these two lines intersect, the image is formed. Object is AB and image is A dash B dash. Object is at 2f and image characteristic you see, first of all real, second inverted, where it formed at 2f, and see size is also same. We may write same size. So object is at 2f, image is at 2f, same size, real, inverted. This is the characteristic. Now we are going to see the fourth case, D, A, B, C, D. Now in the first case, object was at infinity. Second case, the object was beyond 2f or in between infinity and 2f. And third one is at 2f, and fourth we will take object in between f and 2f. So when object is in between f and 2f, so in that condition, see carefully, how the image is formed. Let this point is f and this is 2f. So it is here f, 2f. The object is in between any point. The object is AB in between f and 2f. Let us see the image. First ray always take parallel to the principal axis, always passes through focus. Second ray passes from optical center O. This is point O. We may write here undeviated, no bending, no change in direction. Image formed. Here these two lines intersect. See the position. Here image formed. Inverted image. So it's four characteristics. Keep in mind. First, as it is real, inverted, right side it is formed. Now see, beyond 2f on right side and magnified. Magnified means larger than size of object. So these are the four characteristics. Condition E, when object is at 2f, to see this situation, 2f, f is here, f, 2f, position of lens, here optical center, object is at focus, A, B. First ray, same like as parallel to the principal axis, always passes through focus. Another second ray passing from the optical center O, undeviated. These two rays becomes parallel. Parallel line meets an infinity. It means that image will form on right side at infinity. So the four characteristics of the image real, right hand side, inverted, at infinity means highly magnified, and where it will form infinity. It's clear. Now the sixth, A, B, C, D, E and F. When object is in between F and a focal point F and optical center O. So to show it, see carefully. F, 2F, 2F, F. Object is in between this object AB. First ray parallel to the principal axis, always passes through focus. Second ray passes through optical center, undeviated. This is convex lens. See here in it, the distance between both the rays goes on increasing when we move this side. So these two rays can never meet on right side. So variable image the formed. So to see the exact location of the image, let us proceed the both rays backward. Image A dash B dash is formed here, virtual image. So here in the this image is formed in the side of the object, it means in the left hand side, and erect image is formed. So see the characteristic of image here. The four characteristic of the image. The first, it is virtual. Virtual image cannot be obtained on the screen, whereas real image can be obtained on the screen. So virtual image is always erect image, not inverted. Larger than size of object, larger in size. This is called magnified. And final, beyond focal point F. This is images formed. So by the convex lens, here are the 6 cases under which the image is formed. Now we will see image formed by the concave lens. Now image formed by concave lens. Here it is under 2 cases explained, whereas in convex lens is under 6 cases. So in concave lens under 2 cases A, when object is in between infinity and focal point anywhere. Two F, 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 2F. Let here is object. We take first ray parallel to the principal axis anywhere, either in convex lens or concave lens. In convex lens always pass to the focus, but in concave lens it is divergence seems to appear to come from concave lens. So it will go in this direction. And second ray, either in convex lens, concave lens passes through the optical center, it's undeviated. So these two rays cannot meet on right side. So image will formed here of object AB, A dash, B dash here. So see the characteristic of this. 4 characteristic. First, in same side it means virtual. Virtual images are always erect. Third, between F and O, smaller in size. Smaller in size means diminished. In a bracket we may write smaller in CD size. And here in second case, we take when object is in between focal point F and optical center O, in between. See very carefully. Point F. This is 2F, F, F, 2F. This is the principal axis lens. It is needed to make a concave lens here. This is optical center O. An object is here. AB. First ray parallel to the principal axis seems to come, diverges in this direction, seems to come from focus. First ray go. Second ray passing through the optical center, undeviated. It is in this direction. These two rays cannot meet. So where these two intersect, A dash, B dash, there is smaller images formed in between O and F. So to see the characteristic here, virtual erect between O and F, diminished, smaller in size, diminished, or this diminished is called smaller in size. So the whole image formation we are taken in tabular form. In case of a convex lens, see, the first image is this. Object at infinite of larger size. Second side focal point you will take f2 and this side f1. So image is formed at 2f, very small size, real and inverted. At infinity, second size at focus is formed, highly diminished, very small size, real and inverted. Second case, when object is beyond 2f, but not at infinity. See the second. It formed between f and 2f, between f and 2f, smaller in size, so you may write diminished, real and inverted. In the third case, when object is at 2f, see this diagram when we have taken, the image is at 2f, real, inverted and of same size. Image is formed in case of this convex lens. So we may write at 2f, the position is at 2f2 on another side, same size. It can also be taken as neither diminished nor magnified, real and inverted in the image. Fourth, the object is at between f and 2f. Here, according to the diagram, here in this convex lens, in between f and 2f, beyond 2f, larger size, real and inverted. See, beyond 2f, larger in size means magnified, real, inverted. The fourth case. Now see the fifth case. When object is at focus, image formed at infinity, real, inverted, if it is formed at infinity, very highly magnified, very larger image. So when object is at f, it is formed at infinity, called highly magnified, real and inverted. And the last six, between f and optical center O in the diagram. In case of a convex lens, it forms on the same side first, beyond focal point, larger in size, erect and virtual. So, if object between f and O, its form beyond f1. Beyond f1, my mean to say in same size. Larger in size, we may write magnified. It is erect. and virtual. So due to the convex lens, in all 5 cases, this image is formed real and inverted. In all 5 cases. But in the last case, it is erect and virtual. Now this is time to see in case of concave lens, when object is kept anywhere in this concave lens between optical center O and infinity, anywhere in between, the very small size erect virtual in between 2f. So first is in between infinity to f. So it's formed between f1 and O. f1 means same side. This can also be written f1 at every places. It is smaller in size. Erect virtual. And the last second, C, object in between optical center and O. This is beyond f. Here in the previous case it is beyond f1, and when object is in between O and f, it is between f and O, is smaller in size, erect and virtual. So this is a tabular representation. See carefully, images formed by the convex lens and the concave lens. So this is for a topic only. Thank you and have a nice day to all.